In number 11a, it says graph y is less than or equal to negative 2x plus 5. So I'm going to graph this first as a regular line, y equals mx plus b, by plotting my y-intercept first, which is 5. And then my slope here is negative 2, which would mean down 2 and to the right 1. Or up 2 and to the left 1. Remember, with inequalities, if you have less than or greater than, you use a dashed line. If you have less than or equal to or greater than or equal to, you use a solid line. So in here we're going to use a solid line. Then also with inequalities, we need to shade. Okay, there are two ways to shading. One is you can use a test point. The easiest point to test is 0, 0. So you would plug in 0 for x and y. And we get is 0 less than 5. It is, so we shade on the side where 0, 0 is. Okay, without using a test point, what we could do is look at that y is less than or equal to x. So we're going to shade where the y's decrease, where the y's get less, which is on this side of the line. Part B, name two ordered pairs that are solutions. In order to be a solution, because this is a solid line, we can pick any point on our line or any point that's on the side we shaded. Well, 0, 0 is a solution because we already solved up here and it worked. Another possible point, I'm going to pick negative 4, 1. That's a solution because it falls in the shaded region. Name two ordered pairs that are not solutions. 6, 6. Because it is not in the shaded region. And another one would be like 8, 1. 8, 1 is over here. It is not in our shaded region. Part D, is 1, 5 a solution, why or why not? So 1, 5. 1, 2, 3, 4, 5. 1, 5 is over here. 1, 5 is not a solution. Because the point does not lie on the line or in the shaded region. And that's using the graph. We could also plug 1, 5 into our equation, and we can see if the inequality produces a true statement. Okay, in number 12, we have to graph y is greater than 1/2 x minus 3. So I'm going to do negative 3 as my y-intercept, and then 1/2 is up 1 to the right 2, or down 1 and to the left 2. Now we have a greater than. With a greater than, we use a dashed line. Okay, without using a test point first, here the symbol opens towards the y, which means we're going to shade where the y's get greater. Do the y's get greater above this line, or do the y's get greater below it? They decrease below it, and they increase going above it. So this is where we're going to shade. However, we could use a test point. 0, 0 is not on the line, so that would be the best test point to use. And we get 0 is greater than negative 3, which is true, so we definitely needed to shade on the side where 0, 0 was. Name two ordered pairs that are solutions. Well, this time we cannot pick any on the line because it's a dashed line. Anything on the line is not a solution, as well as anything below our line. So now this time, 0, 0 works. And then another point that would be a solution would be 1, 6. And again, for both parts B and C and numbers 11 and 12, answers are going to vary. Okay, name one that is not a solution, or name two ordered pairs that are not solutions. Well, if it's on the line, such as 2, -2, it is not a solution because it's on the dashed line, and dashed lines are not a part of our solution. Another one that would not be a solution would be -3, -8. All right, is 4, -1 a solution? Let's see, 1, 2, 3, 4, -1. This falls on the dashed line. 4, -1 is not a solution. Because it is a point. On the dashed line. Okay, you can also test it in the inequality, and then you'll see that it does not produce a true statement, so therefore it is not a solution. Okay, in 13, a basketball team is plotting the number of three-point shots made this season. The following table displays the data where X is the game number and Y is the number of three-point shots made so far this season. Find the line of best fit. Round to the nearest hundredth. So again, in our calculators, we can calculate the line of best fit. So in the calculator, we can go into Stat and Edit. And in here, we're going to enter in our X list into list 1. I'm going to highlight my list name, hit clear, then enter. So I'm going to enter in 3, 8, 13, 21, and 35. Then I'm going to go over to the number of three-point shots and enter them into my list 2. So 6, 18, 26, 44, and 70. Always double check all of your points that you enter, or every data entry that you enter. One number off is going to affect your line of best fit. Okay, then for your line of best fit, you could go to Stat, and then you're going to scroll to Calculate up at the top. We want option number 4. Notice it has the AX plus B. This is going to produce a line. Okay, we can automatically hit enter. I do not have Stat Wizards on, so the entry could possibly be different. And we go to Done. And we get Y equals, A is our slope. It says round to the nearest hundredth, so that's 2 decimal places. 1.99x plus B 0.95. Okay, now the entry for this could have been a little bit different. Let me just go back real quick into my mode and turn the Stat Wizards on. Okay, so if I go back into my Stat, Edit, you entered in your list, you go to Stat, Calculate, we want option 4 for linear regression. So now our entry is a little bit different. Our X list, make sure you have the appropriate list name. It should be list 1. The Y list should be list 2. The frequency and store linear equation you shouldn't need. And then just scroll down and hit enter. Okay. Alright, so then for part B. How many three-point shots will they have after their 47th game? So X represented the number of games. So I'm going to enter in 47 in for X into our equation that we got in part A. So we got 1.99. And then we get 94.48. So we actually want to round this and say about 94 3-point shots. Okay, they're not going to take 0.48 3-point shots. Part C. Approximately how many 3-point shots are they scoring per game? Okay, this would be our slope. Okay, 3-point shots per game is your rate of change. And our rate of change here is 1.9. So we can approximate and say about 2 3-point shots per game.